Hello, welcome to CXO Talk. This is episode number 59. I am Michael Krigsman, and I'm here with my deliriously excellent co-host, Vala Ashar. Vala.
Michael, thank you.
Deliriously excellent. Have you ever been called that before?
I have not. That's a very good
And
introduction.
that is a high compliment.
Yes, thank you, sir.
All right. And we have an extremely interesting guest today, Dr. Englin Go, who is the Chief Technology Officer of SGI, Silicon Graphics. And Dr. Go is really a pioneer in high-performance computing.
One of the top 25 chief technology officers in the world by InfoWorld.
Mm-hmm.
So good evening. Oh, good morning, Dr. Go.
Yes. Yeah, it's 3:30 a.m. where you are. Or 3 a.m.
I'm very pleased to be here.
Thank you, sir.
It's I have to say I feel a little bit guilty because you look given that it's 3 a.m. in Singapore where you are, you look completely wide awake.
The timing will be just great for breakfast right after this.
For breakfast.
For breakfast.
Well, I think Dr. Go wins the long distance CXO award
You definitely win the long
after
distance.
59 shows. So.
Yes. So Dr. Go, tell us briefly about your professional background. Tell us, you're CTO of SGI. What does that mean? What do you do, and how did you get there?
Well, I've been with SGI. Well, SGI has gone through many changes, but I've been with the company now coming up to 25 years. CTO for more than 10. And my role really is split between, I'd say, 50% in the field with the sales team, the sales analysts, and the other 50 back at headquarters and engineering, and basically to cross-pollinate ideas between the two sides. So I travel a lot.
Travel around the world visiting your customers.
Yes, indeed. And customers worldwide, from NASA in the US, Professor Stephen Hawking in the UK. So it's an interesting job, going around meeting customers who are doing profound things. Some are doing things that are of immediate importance, like the professor who made a discovery with regards to stock trading that got the SEC FINRA to change your rules recently, all the way to gravitational waves that Professor Hawking has been talking about recently.
Yeah, I recently watched a video where you talked about technical computing, and you essentially said there's two elements with technical computing. There's the data collection part of the computing, and then the modeling and simulation part. And so for our audience, can you briefly speak about high performance computing and what is it, and elaborate on the two components that you had mentioned?
Mm-hmm. So on the high performance computing side, there are really two kinds. One where you build these big experiments, big instruments, like the radio telescope they are building in Australia, called the Square Kilometre Array, or instruments such as DNA sequencers, right? So these are instruments that generate data, and then the data comes in to the high performance computing system. We run analysis, simulation on them, and it produces output. That's the first kind. The second kind is where there is no real massive data input to the system. What you do is you build models to try and simulate the natural world, for example, or simulate the heart, for example, where you don't put as much experimental data in first, but what you do is instead to build computer models, run simulation to see how close it matches, how close the output of those simulations matches the real world.
Sure. So speaking of, you just mentioned the heart. I know that there's lots of use cases and clients of SGI that leverage your technology and innovation to build better products for entertainment, for biosciences, reducing hardships and answering profound questions. And we'll talk about that as with your experience with Professor Hawking. But you mentioned the heart and modeling from cells to proteins to ultimately organ levels, and the entire human heart. With I believe in one of your case studies spoke to 1 billion points of data to represent just a single heartbeat, just one heartbeat, billion data points. And now you want to simulate an entire functioning heart. What does that take in terms of sheer equipment and racks of equipment, and and are we there today? Can we go beyond a single heartbeat?
Well, it's always a trade-off between resolution and the size of the object you want to simulate. So if you want to simulate a small object, like a cell, for example, not the entire heart, you can simulate it at very high resolution. But if you try to simulate something bigger, like the heart itself, or even the whole human body, the resolution has to come down. Today, the largest system we've installed is at NASA. It is about 200 racks. So that gives you an idea, 200 cabinets, right? And that is one of the largest systems in the world. And it is used to simulate the entire Earth probably at, I'd say, 10-kilometer resolution. So you can then get better resolution if you reduce that area, for example. So it's a trade-off between resolution and size. But at 200 racks, we're talking, this is what the state of the art is in terms of the computing power available today. Wow. That's on the Earth scale. So we have also customers who are on the other side of HPC, who take in experimental data, massive amounts of data. And here you have the most recent one is a team of scientists in different parts of the world using our systems to try and assemble the entire wheat genome. I learned this only recently, that in fact the wheat genome is bigger than the human genome, about 5 times bigger. The bread wheat, the wheat that we eat, make big bread with. And there's so over the years, human manipulation of the wheat has improved the yield tremendously. But more recently, that yield curve has tapered off. So it is about quite a worrying trend. So the team of scientists got together to try and sequence and then assemble the wheat genome and analyze it. But then it is not as simple as you might think, because the size of that genome 5 times bigger than us. So one could say, of course, it's not true that wheat is 5 times smarter than us.
Unbelievable.
Is there a relationship? Oh, go ahead. I'm sorry. Please, I interrupted you.
Yeah, so massive data input, right? And you imagine 17 billion base pairs, right? So you can imagine a string of characters 17 billion long.
Wow.
Human is 5 times larger, right? But then what comes out from the DNA sequences is not a nice long 7 billion long string, but all jumbled up. Mm-hmm. So it's like a jigsaw puzzle with so many pieces that you try to assemble without a picture in mind. Right? So if you're doing assembly, you don't have a picture of that jigsaw puzzle, so you try to figure that out statistically.
That's incredible.
So work is ongoing to try and fully assemble, then analyze the bread wheat genome, which is big. That's another application.
Mm-hmm. Is there a relationship between scientific data and analysis that you were describing and the predictive analytics that are used by companies such as Facebook or Amazon?
That's a very good question. And in fact, the two groups, right? The analytics people, they are more from the enterprise world, and the scientific people who have also been dealing with data, but different kinds of data. And more we are seeing similarities between the two sides. Yes, and you can also see that although we came from the scientific world side, more recently we're starting to see new customers in the enterprise side. PayPal, postal service of a country. We see SEC, FINRA using the results of our work. So these are examples more on the enterprise side. And basically, you are trying to either do search or discovery, or things that are in a spectrum in between. You know, in search, basically, you have a huge haystack, and your goal is to find the needle in that haystack, and you have a clear idea what the needle is.
Mm-hmm.
In discovery, at the other end of that spectrum, sometimes you're not quite sure what the needle you're looking for is yet. And what you're trying to figure out is to get, for example, apply more uncertain type application that can handle uncertainty better, like machine learning, to try and get the machine to tell you what you should be looking for. That's the other end of the extreme.
Sure.
But of course, you have users in between. And although I can't name who is doing what in particular, you can see typically one way to look at where they sit, to classify these customers in the enterprise data analytics area is in this spectrum, in search, discovery. Search is where you're very certain, deliberate, and you're clear about what you want. The only problem is that your haystack is huge.
Right.
Discovery is more where you have more uncertainty. You're dealing, even at the extreme, dealing with fuzzy logic and AI to try and get the machine to guide you towards a profound discovery. Or even serendipity, which I call, which is even further out, where you start out with a goal, but the machine eventually guides you to a different, even more profound goal. There's this story, right, about serendipity that you can relate to, and then think of how the analytics people, like the customers I mentioned, would use. It's a story of how Raytheon, the key inventor of Raytheon, was asked to design a radar. And I don't know if I've got this story precisely correct. My understanding that one day when he walked into his lab, someone forgot to switch off the radar. The chocolate bar in his pocket melted. And a year later, I think they started to build the world first microwave oven. So it's serendipity, right? You started out thinking you're going to build a radar, but you also built a microwave.
Wow.
That's the story I heard. I have to verify this. But that gives you an idea that in analytics, same thing, right? You can be very deliberate on one end of that spectrum. The only problem is that the data you're looking through is huge, or complex, or needs to be cleaned up. At the other end of the spectrum, you get higher uncertainty, and you want machine to help you.
Can you talk a little bit about predictive analytics and modeling and simulation in terms of reducing hardship? As an example, understanding data from earthquakes and how they may, help improve our readiness for tsunamis.
Yeah, we have a user at the Earthquake Research Institute in Japan. Their research, the last time I checked, was associated with when an earthquake occurs and they know where it is. The goal is to figure out how the shock waves propagates out from the center.
Sure.
And that how and when, by the time, will provide a few seconds of warning to people further out. So that's on land. So that's an important piece of work. The other one is, of course, to run simulations to figure out that if an earthquake occurs out in the ocean, how would it come in how will it interact with land when it reaches land? Typically, tsunami waves, from what I understand, travel at about the speed of a jetliner. So the further out it is, the more time you have. But you also want simulations or pre-run simulations to tell you if it is of this characteristic, how will it affect land when it arrives? So this is these are all pretty profound ways systems are being applied today.
Sure.
NASA has been running simulations with NOAA for hurricane landfall. So hurricane typically starts out in the ocean, and you want to run simulation to try and figure out as accurately as possible the point of landfall to within a tight enough tolerance, right? You don't want to say I predict landfall to within these 300 miles. Then you're going to warn too many people that eventually may not see that the effects of that landfall, and then the effects, the effectiveness of your warning actually depreciates. So you want to tighten that area where you think the landfall will be, and that requires massive simulations. That's just what NASA and NOAA do.
Dr. Goh, we have a question from Twitter. Arsalan Khan asks, who should analytics people, I think he means inside a business, who should analytics people report to? The CEO, the CIO, Chief Operating Officer, or should it be its own executive position? So in the enterprise, organizationally, where do you think analytics should sit and report to?
Analytics or analysts, data engineers, data analysts, data scientists, depending on their roles, I think would be in the future very much like design engineers, architects, principal engineers that we have. They have a role within organizations that requires that function. So today, our design engineers are typically in engineering because that's where they are needed. And we also have highly technical people, engineers out in the field because they are needed there.
Sure.
So I would suspect that you get analysts, data analysts, data scientists in different departments where they are needed, in finance, in marketing. But depending on size of companies, some companies may centralize them. A chief data officer, right?
Yeah, absolutely.
So
Chief data officer.
So you'll have, so in the future, the analysts then will you're saying will very often be spread throughout the organization so that because they become a standard part, data analysis becomes more a standard part of the operations of a particular part of the business, of many parts of the business. And so they'll need their own data support.
Yes, and if there is a need for centralization, we have centralized. Right? Like in the past, CTOs have the role where a lot of the top engineers, I used to have that too, report through to it. The chief and principals report to it, and then as the functions within organization or the structure of the organization changes, I had also moved those engineers back out to the engineering organization. So I think these things are quite dynamic. Even for engineers, design engineers, things do change. So you might decentralize and centralize. I did hear of a philosophy, company organization philosophy from a very senior and experienced executive, and he said that every few years you need to change things. Right? One way to change regularly is to decentralize, then centralize it again, and decentralize again over the year.
Right. Always adapt.
Sometimes it is done deliberately.
Sure.
But sometimes it's done out of necessity. So you'll get both models, I believe.
Mm-hmm. And I want to go back also, we're talking about analytics and analysis data in the enterprise. Do you think, are the enterprise data analysis problems, like in marketing or predictive analytics, for example, are these simpler problems than what scientists are, like, for example, at NASA are facing? Is that fair, or is that not an accurate characterization?
No, actually, it depends on the questions you want to ask, but if you ask more profound questions, I'll give you an example later. Both sides are just as tough, right? Both sides are just as difficult, both on the HPC side and enterprise. First, they are similar in the sense that the amount of data is massive. From instruments, I hear that the square kilometer array, when it completes, could be generating 1 exabyte a day. Right? I fell off my chair when I first heard it.
Wow.
Right? Even if they did 100-to-1 data reduction before they store them, you have to store 10 petabytes a day. You can imagine the scale of that thing. And then now you have to analyze it. The Large Hadron Collider, right, is also generating data, not of that magnitude, but even if you're talking 10 petabytes a day generated, that's a lot of data to analyze. By the way, we are one of the tier 1 storage sites for the Large Hadron Collider.
Wow.
You may have heard they recently discovered the Higgs boson, which
Right.
in general terms it means that they figure out where mass comes from. The Nobel Prize was awarded this last year for it. So on the HPC side and instrumentation side, massive amounts of data. And then on the enterprise side, data can be huge too, although not as big as I've described, but it can be quite huge. The question is, do they want to run analysis or predictive analysis or ask questions of the data? And when they say data, do they mean all of it? Do they mean part of it? Or do they mean cross-discipline? I think the implementation of systems are not that big in the enterprise relative to HPC today. So they are more conservative in the way they ask questions and more conservative in the way of the size of data they would like to analyze. So once given the same tools, right, you'll see them starting to go much larger scale. On the search side, you start to see Hadoop now being used, where you would put massive amounts of data into 1,000-node Hadoop. Some of our customers are running search. So the enterprise side is starting to catch up in terms of size.
So, as the Chief Technology Officer, I'm sure part of your responsibility is defining, where high-performance computing will be 2, 4, 5, 10 years from now. And we've all read so much about the Internet of Things, Internet of Everything, and certainly based on whether analyst organizations have quite a large range in terms of the IoT. From, by 2020, we will have somewhere between 25 to 30 billion, one leading analyst predicts. Another leading analyst predicts an order of magnitude more, in the 200 plus billion connected devices and sensor technology and wearables and so on and so forth. Can high-performance computing keep up with what appears to be a massive explosion of stuff connected to the internet?
Yeah, that's your 1 exabyte a day equivalent on the internet side, right? Yes. On that note, sensors, right? I recently was talking to one of our customers in the life sciences area, and they are involved in a project to get a mobile DNA sequencer. Right? The idea is, for example, on your iPhone, you have an attachment, and when you're walking around the supermarket, and if you look at salmon, right, you just want to be sure it is salmon. Right? Assuming you get permission to take a small sample, put it into that device, and the goal is it'll tell you, yes, it's truly salmon, for example. So you can imagine, right? Yes, sensors are getting very sophisticated, mobile, and they're on your person.
Sure.
And yes, and the amount of data that will be assembled will be huge. The question is, do you want to ask question of the entire set of data, if you have access to it, and if you want to, because you believe the insight will be better, then there will be a demand for these kinds of machines. Right? We have one user who just dumped the entire Wikipedia into one huge memory machine, and then just ran a simulation, right? Wrote a script in one day, and ran a simulation that connected by lines all countries mentioned in the same year in Wikipedia, and ran that across all the years since the 1800s till today. And immediately there were some insights, right? Like, for example, before a conflict, you see a very dense connection of lines amongst those countries related, for example.
Wow.
And perhaps could this be a useful prediction tool? Like even Wikipedia could be a prediction tool. So these are profound times, yeah.
Absolutely.
So when you're looking at problems, one of the important criteria that you are considering is how profound is this question or is this problem? It seems like that's a key issue for you.
Yes, as there is high certainty in the search area, and then as you go towards more and more uncertainty, your hope is that it gets more profound, or that the answer you get, or the final outcome, is a profound one. Extreme profound one would be where you always thought that this is going to be the answer, and all you want is confirmation, right? Through that analytics, but in the end, it tells you totally something different, right? Just like this story of one of the professors that used the Pittsburgh supercomputing system that we supplied to. He did an analysis of the May 6th crash of 2010 in the stock market, where I think within 20 minutes the Dow Jones dropped something like, if I remember correctly, 1,000 points. Yeah, it was a big event. He ran the analysis and realized that trades, for a start, someone wanted to trade 1,000 shares. A lot of trades were broken up into 99 shares lots, and then traded in these small pieces. It is perfectly fine. I mean, people do that for good reasons. But what was profound was that although that was the original intent to confirm that was the case, that was a discovery of his part, not even the intent. He didn't even know for sure that was going to be the discovery, but he discovered it. Sure. But what was more profound, as he analyzed further, was that people were sending in massive amounts of trades and then canceling them. That was a massive amount of these small 99 trades and then canceling them. Right. Could this be the reason why there was congestion?
Sure.
This is why there were recent glitches in the stock market trading system.
Sure.
So these were the discoveries, and in fact, the SEC took note of his paper, of his report, and as of December last year, they changed the rules. Even odd lots of less than 100 shares are now reported.
Wow. Mm-hmm. Wow.
In the past, they're not. That's how you can fly under the radar.
Right. Right. Well, so many of us can claim that we work with some of the smartest customers in the world, but you certainly can make that claim.
You really do,
because you work with Stephen Hawking. So just tell us what's that like. Before we talk about how he uses computing and your relationship with him, I saw you presented at his birthday ceremony. But just how, what is it like working with arguably one of the smartest, person on earth?
Well, I must say it's a great honor.
Yes, yes.
Very sharp, and what's key is also, in addition to his intelligence, is his determination. And he loves The Simpsons, the cartoons, right? You go into his office, you will see figurines of The Simpsons there. Yes, it's a great honor, and so when you talk to him, you will have to be patient, because you say your part, and then you have to wait for him to put in the effort, right, to guide the cursor with a sensor on his cheek to put together a sentence reply for you. So it's something that you learn. You have to wait for the answer, because every word he answers you with is highly precious. It takes him a lot of effort to put it together. So you're very appreciative, right? And you'll be very concise with his answers. I remember many years ago, not recently, but many years ago, I was asked to do a brief presentation of what the system would be like when we installed it. I did a printout of slides on paper and then stood in front of him and presented. And then I would then pause and I would walk behind him and look at the monitor as he crafts his questions. So yes, it's you get to understand determination.
That's incredible.
Yeah.
And how is Professor Hawking using computing? What projects are you working with him?
We've built one of the largest shared memory machine for him. The idea is that this is a single node, not a cluster. Right? It looks just like one huge big laptop. We're talking about terabytes of memory in that system.
Wow.
This is so that it's easy to work with. So that's Professor Hawking has been known to give us this quote. He says, the reason I use this machine, I paraphrase, the reason I use this machine is because it allows me to be a scientist, not a computer scientist. He actually said that. So the idea is that he wants a machine that is powerful, yet easy to use, and not have to make him become a computer scientist to use it. And that's something I learned from him. And from him, I've learned to design systems that are scientist-friendly. Soon, I will also include the term analyst-friendly. The two sides of it.
Scientist ready and analyst ready. That's great.
Yeah, friendly, right? Scientists and analysts friendly.
Sure.
So that you feel that when you are approaching this supercomputer, that you are just like as though you're approaching your own laptop. It's just big at the back end. In a way you use it.
Do you believe in the retail space, Dr. Goh, with the potential for electronic wallets and iBeacon technology, for example, with Apple? We talked earlier on the show about adding intelligence to smart devices will ultimately lead to a point where we can model and simulate and have predictive analytics in terms of buying behavior based on the fact that we're essentially carrying a remote control for life in our pocket called phone. Have retailers reached out to your organization to try to understand whether that's an opportunity for them to grow their business using big data and large analytics?
Mm-hmm. Absolutely. Retailers from people selling goods in supermarkets all the way to a PayPal, right, who does retail in terms of payment. And analytics is already done at many levels to try and place merchandise in a certain strategic way to improve sales, right, by looking at buying receipts and buying patterns, all the way to one of our customers who are using systems to analyze users who are using their payment system, because they don't quite know when someone logs in to initiate a transaction to pay for something using their system, that it is really that person at the other end. So they run analytics to make a decision if it is really that person, and they get a statistical probability answer, and then they make a decision based on that. But this whole thing will move to a new level when you collect a lot more data. You collect data that are on sensors, on everything. I know of one professor, I think is on the East Coast, who published a paper recently that after training, just the accelerometer on your cell phone alone can be used to identify the person based on the gait alone, the way you walk. So if you want to be identified in the future, sit down when you make a call, for example. So these are the kinds of things that are pretty all the way to a cell phone attachment for DNA sequences. Right? You can imagine the amount of data if you want to collect it. Right? And if you do, how will you use it? Is it worth collecting it? Well, that's a good question, right? After collecting it, and you get more profound or more insightful discoveries from that data if you
Sure.
did collect and store it? Or should we just stream it? Should we just run streaming analytics and learn from that stream of data and don't store it? Because storing is becoming a huge issue. One could say that storage capacity has been growing exponentially, or even greater than Moore's law. But the amount of data generated is far exceeds that at rates, in terms of rates. So you have to be quite conscientious about what you store.
Right.
So I think streaming analytics, where you learn as the data passes you by, right, will become more important. Just like humans, right? I mean,
Sure.
we store everything we see, hear, touch, right? But we process it and form insights, memories, knowledge, understanding. We form it as the data passes us, but we don't store that data. Store what we learn from it.
That's right.
So I think that could become more important as storage storing everything becomes untenable. Even storing 10% becomes untenable, as we saw with the square kilometer array.
So to accomplish that, then I'm assuming you need both very powerful computers as well as the right type of algorithms. You need both.
Yes. So precisely, because if you are not storing, it's best to therefore bring in massive amounts of compute power to run all the different angles on that data, because you don't know what you should learn from it.
Right.
Because you won't have a chance to go back to it, perhaps, right? It has passed you. Right?
Sure.
So you want to apply search algorithms, discovery algorithms, data mining algorithms, machine learning algorithms, as many as you can as the data passes you, and that means compute power.
Sure.
Massive amounts of I/O and compute power. And then what you do is store the learnings.
Mm-hmm.
I read a blog. I read a blog that you had written that talked about how you, as a CTO, you spent a lot of time engaging with younger engineers, new engineers, and I was wondering why you thought that was important as a chief technology officer to engage with younger engineers.
Very, very important point. I'm glad you brought it up, reminded me about it. In our company, we have engineers of different seniorities, and then the level above the highest level would be principal engineers.
Sure.
That's roughly about 5% of the entire engineering cohort. And then above that would be senior principal, and then above that would be chief engineers. Amongst the principal and chief engineers, one of the key factor of being in that position is mentorship. I say that a lot all the time. To mentor young engineers as they're coming into our teams. Because when you mentor them young, when you first come in, they launch quickly, they get motivated because there's someone watching over them, and they get advice and guidance from someone that has 10, 15, 20, 30 years of experience. So mentorship is key.
Sure.
And the reason why I focus on that is because of the young engineers. They are exciting bunch, right? They come in bright, enthusiastic, lots of ideas.
Right.
And I've heard one innovator I respect a lot said once that a lot of times it's not getting any more innovations. A lot of times it's for the chief technology officer to filter innovation. Right? And so you want that pipeline coming in at full frame from these young engineers with bright ideas, from our principals and chiefs that will moderate and also come up with their own ideas. But the goal, for CTO, I'm talking about CTO role now, is to figure out what to pick, right? Because you can't afford to invest in them all. That's the big problem.
Right. Well, you started the show. You started the show talking about how much you spend with customers and how you're outside-facing CTO, and it appears to me that would create a certain level of paradox where you're trying to motivate feedback and engage and learn from customers, but there must be an avalanche of requests coming your way. Some of them may be realistic, some may not. So how do you, as a CTO, balance and determine what type of filtering algorithm you're going to apply to this awesome amount of feedback you get from customers?
Well, it's a great question. It goes to show that why you have done 59 shows. Right? You touch on these very key points of my role. Yes, I get lots of feedback. For example, last year I did more than 150 customer engagements.
Wow.
150.
Awesome.
So if you average that out, that's an enormous amount of interactions, feedback. A lot of times, eye-to-eye connection, right? Can also tell you how important that feedback is with the customer. That's why I travel out, shake their hand, meet them, and see how they are presenting their feedback. So feedback is enormous. So what I do is after each collection of trips, I write a consolidated distilled report. I put it up to our teams, and then I join engineering meetings, and I don't make the decisions alone, right? So there is a team. The COO is leading. Our CEO is leading the engineering teams, and within that, there are vice presidents and engineering directors that will have a process to filter that through. So I'm just one of the conduits of providing that feedback, but I do distill it first. I also heard from another great innovator that I respect a lot. Once said that sometimes the customer know what they want and what they say is very important, but sometimes they don't know what they will need in the future.
Right.
You may have a better perspective of that. So you try to keep both of those things in mind, right? I think it is a well-said quote. I think it was Henry Ford who once said that if he had asked his customers back then what they wanted, he probably would have told them that they wanted a faster horse or faster wagon.
That's right.
I think that's what he said.
That's right.
But that's basically that second part of it. So sometimes the customers are very clear about what they want because they are into their workflow every day.
Right.
Sometimes don't quite know what they will need coming up in the future, because even though they're very clear about their current workflow, they may not fully understand all the different technologies that are coming to perhaps even change their workflow in the future. So these two balances and make bets, 3 years out, because you're going to invest now for a product that will come out 1, 2, or 3 years later, and make bets, understanding these two things that are different in customers and feedback.
Dr. Goh, so you spend half of your time talking with customers and gathering their feedback, and then half of your time thinking about the products and technologies and so forth. Which is more difficult? The people side, or trying to figure out the ways to resolve these most profound, or even identify these most profound problems? Is it the people or the technology?
I wouldn't say more difficult, but more, the customer side requires you, in many cases, to go out and meet them, right? That's one, so there's lots of travel, so that actually weighs on you, but I always believe that's highly worthwhile. And of course, customers, there are different kinds. A group where you've known them for many years. The longest customer that I've known coming up to more than 20 years now, right? Coming up to 20 years. That's that group that you are more familiar with, you understand their workflow very well. And then you get this brand new set of customers that are exciting. Now, these requires you to first go in, learn their workflow, or even read a book about high-frequency trading, right? Before you go meet a high-frequency trader, right? Or at least understand what they do. So this one requires a lot more work than sitting in a plane, reading a book about your customer before, or what he or she does before you arrive. Now, those also have a different kind of challenges. Right? So you get the customers you know well, but you always remind yourself, never take them for granted. Always treat them like as though their new customers and make sure they are serviced well, listen well, and approach well. And then you get this new customers that you have to learn their workflows. And more recently, it's about the enterprise side, right? How to do extreme virtualization. What does a CIO do in a bank? The bank recently have been given this huge task since the recent turmoil. Banks within themselves are looking at extreme cost reduction. A number of banks I've talked to, big ones, and have been told to reduce their IT costs, for example, by up to 50%, 50, right? And they've set up divisions called greenfield divisions or divisions of those kinds to look at ways how you can incrementally reduce up to 50% of your IT costs. You can look at the extreme consolidation in one as one example. So you go in and start learning about your workflows, and then after a few sessions, more recently I spent with a bank after a full day of understanding their workflow, and then at the end of it, then you then feel a little bit more qualified, right, to suggest some early solutions. Then you quickly bring that feedback back to engineering to tell them, if this bank went with this solution, these are the things that are still lacking in our products.
Right.
So now you can see the connection. Sometimes it is not building a new product. Sometimes it is tweaking it so that it's more suited to this new workflow. But then we'll have to have our business units tell us that this workflow is worth investing in through a business case analysis. So sometimes it's not just engineering and customers, but also with our marketing teams that will then tell us that, okay, it is worth tweaking the product for this new workflow.
Sure.
So we can see how things work here in this particular example with a new customer.
Sure. So what I certainly my takeaway based on listening to you, and thank you so much for all your shared wisdom, is that today's CTO success is not predicated by how deep and how extensive your technology acumen, but there's an element of social responsibility, there's an element of business acumen, there's an element of mentoring and coaching and customer engagement. So it's just an incredible amount of, again, based on our 45-minute conversation, that you have to, manage and grow in order to be a successful CTO. So, I think that's just remarkable insight and feedback, Dr. Goh. Thank you very much.
Yes, both the discussion, both of the technical side and the people side is very interesting.
Thank you for having me.
It's unfortunately, this has been a very fast 45 minutes, but it is that time.
We could have, if it wasn't for Dr. Goh having to have breakfast, I can go for another hour.
Yes. So it's now almost 4 a.m. in Singapore.
4 a.m. in Singapore. Well, again, for the time of day and the distance and your profound insight, thank you very much, sir. I certainly learned a lot.
Yes.
Michael, Vala, Michael, thank you.
Thank you.
Thank you.
And you've been watching CXO Talk. We have been chatting with Dr. Eng Ling Goh, who is the Chief Technology Officer of Silicon Graphics, and we have learned a lot more about scientific computing and data and analysis than I've heard in a long time. I'm Michael Krigsman with my co-host, Vala Afshar.
I'm going to be having dinner after this, so.
And Dr. Goh, thank you again so much for joining us. And everybody, I hope you'll come back next week when we will be talking with the Chief Information Officer of IBM. Thank you so much.
Bye-bye.
Bye-bye.